All right, I'm going to be talking about question 47 from chapter 8. This is a tube circle problem. A 60-gram handball moving with a speed of 5 meters per second strikes the wall at an angle of 40 degrees to the normal, and then bounces off with the same speed at the same angle with the normal. Okay. It is in contact with the wall for 2 milliseconds. What is the average force exerted by the ball on the wall? So the time that it impacts the wall is 2 milliseconds. That's equal to 2 times 10 to the negative third seconds. And it wants to know the average force exerted on the wall. So this is making an angle. I'll just kind of draw an angle. So here, that looks something like maybe 40 degrees, right? So it's angle to the normal. So that's a spot where we might get tripped up here. I'm not sure if you can really see that. I'll try to make that a little bit bolder. So it's going into the wall, and the normal is this direction, right? Normal to the surface of this wall. We could have drawn this horizontally or something, but I'm just drawing that vertically. It doesn't say anything about acceleration or gravity or anything like that, so it's not telling us it's in a vertical direction. So this could easily just be some type of pool ball. It says a handball, but we're not going to be considering gravitational forces or anything like that in this case. But this angle here is going to be 40 degrees, and then it also leaves the wall with that same angle to the normal, right? 40 degrees. So it's incident, and it has some velocity here, a velocity vector, which is equal to, I think it was 5 meters per second? Yeah, 5.0 meters per second, right? That's clear to see. So it wants to know what is the average force that acts on it. Well, we know that there is going to be, we're interested in the momentum of this particular object, right? The object is coming in at some angle, it hits the wall, and then it bounces off at that same angle. We could ask, what about the components of this particular force, or of this particular ball? We know that the direction of the force, the incoming velocity is in this direction, the outgoing velocity is in this direction. So what is the direction? So the momentum is also in that same direction, because the momentum of each of these things, the initial momentum and the final momentum, are simply in the same direction as the velocities, right? So we know that the momenta are also initially into the wall at this 40 degrees and then away from the wall. So the question we want to know is what is the force that causes this change in momentum, right? There's some force acting over some time. There's some external force acting, the force of the wall that's kind of pushing on the ball. So in many ways we're being asked some information about the impulse that acts on this. It's some external force that acts over some very small time interval that changes the momentum of this object. So does it change? What direction does that force act? Well, this is only a normal force, right? It can only act perpendicular to the wall, so that this force is going to be exerted to the left. There's no force. It can't exert a force in a direction that is parallel to the wall, because there isn't any object, right? There's nothing that actually is pushing the ball in that particular direction. And we also know that because we're told that the ball comes off also at a 40-degree angle, the exact same angle that it was incident at. And that lets us know that the x component, or the component of this momentum along this particular direction initially, is going to be the same before and after, right? So this was our initial momentum, and this is our final momentum, right? In both cases, what do we want to call this? Let's call this the positive y direction, okay? The y component of this initial momenta is going to be equal to the y component of the final momenta, because those are both going, sorry, this shouldn't be a vector here, because we're just talking about the component that's in the y direction. I'm not sure if that's really showing up. Maybe I should write a little larger. Let me draw those a little bit larger. So here was our initial momenta, and our final momenta, and the y component of that initial momentum and the y component of that final momentum. We know that those are going to be equal to one another because there is no external force along that direction, right? Each of these components is going to be is going to be, well, we need to be able to consider the conservation of momentum in both directions. Since there is no force along this y direction, that the direction along the surface of the wall, we know that conservation is going to be conserved. There is a force along the x direction, right, along this direction that is perpendicular to the wall or normal to the wall. So that tells us that here we have this momentum in the x direction initially to the right, and then finally it is to the left. That's the final in the x direction. And so that change in momentum is due to this external force that is being applied by the wall. And we're going to calculate that in just a minute.